Along in this lecture, we find out the area of the shaded region. In the moment, we have a big quarter circle. Inside this big quarter circle, we have this semicircle and this small quarter circle. We know that AO equals to 10 units in its length. Again, our task is to find out the size of this shaded region. Okay, so we know that AO is the radius of this big quarter circle and is equals to 10 units in its length. BO is also the radius of this big quarter circle, therefore it is equals to 10 units in its length. BO equals to 10 is the radius of the big quarter circle. The radius of the big quarter circle, BO, is also the diameter of this semicircle. So the diameter of this semicircle equals to 10, and therefore the radius must be equal to half of it. 10 over 2 is 5. So when you find the center of this semicircle, this point is point C. So BC is the radius of this semicircle. It is equals to 5 units in its length. CD is also the radius of this semicircle. It is equals to 5 units in its length. In the next step, we define the touching point of this small quarter circle with this big quarter circle. This point is point P. We define this point as point Q. And we define this point as point S. We define the radius of this small quarter circle as X. So PQ is the radius of this quarter circle. This small quarter circle is equals to X. Likewise, QS is also the radius of this small quarter circle. Is equals to X according to our definition. We know that ABO is the big quarter circle, and therefore this angle is a right angle. Likewise, PQS is a quarter circle, and therefore this angle is a right angle. These two in a quarter circle, those two angles, no, they're both right angles because it is a quarter circle. So in the next step, we will join point C and Q together by straight line. Actually, point C is the center of this semicircle. Point Q is the center of this small quarter circle. So those two shapes have an axis between them at this point. We define their touching point, this point is point M. And whenever you have an axis between two circles or semicircles or quarter circles, you can implement rule 10. Read again. This small quarter circle and this big semicircle touch each other externally at this point, point M. So they have an axis between them at point M, and therefore we can implement a rule 10. So repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects the circles together passes through their touching point. So in the drawing, we have those two circles that touch each other externally at this point, point P. Point O is the center of this circle. Point M is the center of this circle. The straight line that connects the circles together is of course the straight line OM. And according to this rule 10, the straight line OM must pass through point P, that is their touching point. Again, the straight line OM that connects the circles together must pass through their touching point, that is point P. Or OPM is one straight line. Again, according to this rule 10, OPM is one straight line. So we can implement rule 10 in our drawing. One put in our drawing, the small quarter circle and this semicircle touch each other externally and point them. So we can implement here rule 10 because they have an external between them at point M. The center of this small quarter circle is at point Q. The center of this semicircle is at point C. And the third line that connects their centers together is of course the third line CQ. According to rule 10, the third line CQ must pass through point M, that is their touching point. Or CMQ is one third line. Again, CMQ is one third line according to rule 10. CM is the radius of this semicircle, that is equals to 5. QM is the radius of this small quarter circle, that is equals to x according to our definition. And because of the fact that according to rule 10, CMQ is one straight line, it means that CQ in total must be equal to CM plus MQ. So CQ in total equals to CM, that is 5, plus MQ, that is x. So in total, CQ equals to x plus 5. CQ equals to x plus 5. So here we can implement the Pythagoras theorem on this right triangle QCM. So I'll copy the right triangle QCM in Olympiad, and we will implement on it the Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the square of the perpendiculars. CQ equals to 5 units in its length. It is the radius of the semicircle. We just now found out that the hypotenuse of this right triangle CQM equals to x plus 5. CQ equals to x plus 5. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle COQ that I covered from the original drawing. This right triangle COQ, CQ squared, that is the square of the hypotenuse, equals to CO squared plus OQ squared. So I'll write it down. This will be equation 1. So CQ squared, that is the square of the hypotenuse, equals to CO squared plus QO squared. CQ is x plus 5, therefore CQ squared is x plus 5 squared. And it is equal to CO squared. CO is 5, therefore CO squared is 5 squared. That is 25 plus QO squared. QO is the missing side, so we leave it as it is. So in total, according to equation 1, we should find out that x plus 5 squared equals to 25 plus QO squared. Here we subtract 25 from this equation 1, and get that according to equation 1, x plus 5 squared minus 25 equals to q all square. And again, according to equation 1, we found out that q all square equals to x plus 5 square minus 25. Q all square equals to x plus 5 square minus 25. In the next step, we will join points O and P together by straight line. Point O is the center of this big quarter circle. Point P is the point on the big quarter circle itself. Therefore, OP is the radius of this quarter circle. It is given the question that the radius of the quarter circle equals to 10. So PO equals to 10. PO equals to 10 units in its length. So in the next step, we will implement the Pythagoras theorem on this right triangle PQO. So copy the right triangle PQO in a new page, and we will implement on it the Pythagoras theorem. Here by PT is the derivation for Pythagoras theorem. PQ equals to x, and we just right now found out that the hypotenuse PO equals to 10. It is the radius of the big quarter circle. So actually, this is the right triangle POQ that I covered from the original drawing. So in this the triangle POQ, according to the Pythagoras theorem, this will be equation 2. PO squared, that is the square of the hypotenuse, equals to PQ squared plus QO squared. PO is 10, therefore PO squared is 10 squared, that is 100. And this equals to PQ squared. PQ is x, therefore PQ squared is x squared plus QO squared. QO is the missing side, so we leave it as it is. So in total, according to equation 2, we actually found out that 100 equals to x squared plus QO squared. Here we will subtract x squared from this equation, equation 2. And finally we get that 100 minus x squared equals to QO squared. So according to equation 2, actually found out that QO squared equals to 100 minus x squared. This is according to equation 2. But according to equation 1, we already found out that q all square equals to x plus 5 square minus 25. So we have two different equations for q all square. According to equation 2, q all square equals to 100 minus x square, while according to equation 1, q all square equals to x plus 5 square minus 25. Therefore, we create equation 3 that states that q all square according to equation 1 must be equal to q all square according to equation 2. Q all square according to equation 1 equals to x plus 5 square minus 25, and it must be equal to q all square according to equation 2. Q all square according to equation 2 equals to 100 minus x square. So in total according to equation 3, I should found out that x plus 5 square minus 25 equals to 100 minus x square. Here we will open the brackets of this expression and we get that x plus 5 square equals to x square plus 5 square, that is 25, plus 2 times x times 5, that is 10x, minus 25 equals to 100 minus x square. So in this side of the equation we have 25 minus 25 is 0. After we cancel 25, we left here, and this side of the equation 3, we left only with x squared plus 10x equals to 100 minus x squared. So according to equation 3, x squared plus 10x equals to 100 minus x squared. Here we add x squared for this to this equation, equation 3, and you get that according to this equation, equation 3, x squared plus x squared is 2x squared plus 10x equals to 100. So here we will subtract 100 from this equation, equation 3, and finally get that according to this equation, equation 3, 2x squared plus 10x plus 100 equals to 0. So here we divide this equation, equation 3 by 2, and finally we get that according to equation 3, 2x squared over 2 is x squared, plus 10x over 2 is 5x, minus 100 over 2 is minus 50, equals to 0 over 2 is 0. So in total, according to equation 3, we actually found out that x squared plus 5x minus 50 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, capital A, capital B, and capital C in this general quadratic equation are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times A times C over 2A. In our specific quadratic equation, that is to say x squared plus 5x minus 50 equals to 0, the variable that we are looking for is of course x. The coefficient a equals to 1. The coefficient b equals to 5. And the coefficient c of our specific quadratic equation equals to minus 50. Again, the variable that we're looking for is x. So all that is left to do is to put the data of our specific quadratic equation inside this general formula for x. In this way, we find out the value of the values of our specific quadratic equation. Okay. We know that x, according to our definition, x is the radius of this small quarter circle. So we will put the data inside this general formula for x in order to find out the radius x of this small quarter circle. And we get that here x equals to minus b. B is 5, therefore minus b is minus 5 plus minus square root of b squared. B is 5, therefore b squared is 5 squared, that is 25. Minus 4 times a times c. A is 1, c is minus 50. So minus 4 times a times c is minus 4 times 1 times minus 50. Minus 4 times minus 50 is plus 200. So in total, minus 4 times AC equals to plus 200. So it is 25 plus 200 over 2A. A is 1, so 2A is 2 times 1, that is 2. So in total, we found out that x equals to minus 5 plus minus 25 plus 200 is 225 divided by 2. So total we found out that x equals to minus 5 plus minus, the square root of 225 is 15 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 5 minus 15 over 2. Minus 5 minus 15 is minus 20, and minus 20 over 2 is minus 10. So according to the first solution for x, I found out that x equals to minus 10, minus 10, and because of the fact that x is the radius of this small quarter circle, x is a length, and as a length, it must be a positive number. Therefore, it is impossible that x will be equal to minus 10, that is a negative number, so we cancel this solution. And we have to only with the second solution for x, that x equals to minus 5 plus 15 over 2. So x equals to minus 5 plus 15 is 10, and 10 over 2 is 5. So the second solution for x is that x equals to 5. So if you found out that the radius x of this small quarter circle is equal to 5 units in its length. Repeat again that our task is to find out the size of this shaded region. What is the size of this shaded region? Actually, from the drawing, it is very easy to see that the size of this shaded region in total will be equal to the area of the big quarter circle A or B. minus the area of this semicircle minus the area of this small quarter circle PQS. But again, in total, we should find out that the area that we are looking for in this question, that is the area of this shaded region, in total it is equals to the area of the big quarter circle AOB minus the area of the semicircle minus the area of the small quarter circle PQS. It's very easy to see from the drawing that if you subtract from the area of this big quarter circle AOB those two areas, you get exactly the area of this shaded region. So the area of the big quarter circle minus the area of the semicircle minus the area of this small quarter circle PQS, in total it must be equal to the area of this shaded region. We know that the radius of this big quarter circle AOB equals to 10, and therefore the area of this big quarter circle AOB must be equal to pi 10 square over 4, because it is a quarter circle, so we have to divide the area of the circle by 4. So it is pi 10 square over 2, pi 10 square over 4. The area of the big quarter circle equals to pi times 10 square over 4. Pi times 10 square over 4. And from the area of this big quarter circle AOB, we have to subtract the area of this semicircle. We know that the radius of this semicircle is 5, and therefore the area of this semicircle must be equal to pi times 5 square over 2. Pi times 5 square over 2. Minus the area of this small quarter circle PQS. We already found out that the radius of this small quarter circle is 5, and therefore the area of this quarter circle must be equal to pi 5 square over 4. So the area of the small quarter circle PQS equals to pi 5 square over 4. Because of the fact that we are talking about a quarter circle, we have to divide the area of the circle that is pi 5 square by 4. So total, we found out that the area of the shaded region equals to pi times 10 square over 4. 10 square is 100. Therefore, in total, this expression equals to 100 pi over 4 minus 5 square is 25. So total, this expression equals to 25 pi over 2. So we multiply both the numerator and the denominator of this expression by 2 in order to have a common factor with this expression. So 25 pi over 2. So we multiply the numerator 25 pi by 2. 25 pi times 2 is 50 pi. And 2 over 2 is 4. We just multiplied both the numerator and the denominator of this expression by 2. We got that this expression equals to 50 pi over 4. And we have here minus 5 squared is 25, so in total this expression equals to 25 pi over 4. So here we take 4 as a common factor of those three expressions. 100 pi minus 50 pi is 50 pi. 50 pi minus 25 pi is 25 pi over 4. 25 pi over 4. In terms of numbers, 25 pi over 4 is 19.635 square units in its size. Repeat again, actually found out that the area that we are looking for in this question, that is the area of this green shape. In total it is equals to either 25 pi over 4 square units in its size, or in terms of numbers it is equals to 19.635 square units in its size. So the next step, I'll start the lecture. In this lecture, our task is to find out the area of this shaded region. So, in the drawing, this is the big quarter circle. Inside this big quarter circle, we have those two shapes. This is a semicircle and this small quarter circle touch each other externally at this point. And our task, we also know that AO, that is the radius of this big quarter circle, equals to 10 units in its length. Again, our task is to find out the size of this shaded area. So first of all, we define the center of this semicircle. This point is point C. We define the touching point of this big quarter circle with this small semicircle. This point is point P. We define this point as point Q, and this point is point S. AO is the radius of the big quarter circle, that is 10, and therefore OB is also the radius of this big quarter circle, that is equal to 10 units in its length. Because of the fact that BO is also the diameter of this semicircle, so the diameter BO of this semicircle is 10, and therefore the radius must be equal to 5. Now we'll do CB of the quarter circle equals to the radius CQ, each of them is equal to 5. In the next step, because of the fact that AOB is a quarter circle, this again is a right angle. Likewise, because of the fact that PQS is also a quarter circle, this is a right angle. So, those two, this is the semicircle and this is the quarter circle, they touch each other externally at this point, point M. And now you have two shapes that touch each other externally, you can implement rule 10. So if we on rule 10, according to rule 10, if two circles touch each other externally, then the straight line that connects the centers together passes through their touching point. So in the drawing, we have those two circles that touch each other externally at this point, point P. The center of this circle is at point O. The center of this circle is at point M. The straight line that connects the centers together is of course the straight line OM. And according to this rule 10, the straight line OM must pass through the touching point, that is point P. Again, the straight line OM must pass through point P, that is the touching point. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. So we can actually implement rule 10 in our drawing. Why? Because in our drawing, the semicircle touch this small quarter circle at point M. The center of this semicircle is at point C. The center of this small quarter circle is at point Q. The straight line that connects the centers together is of course the straight line CQ. And according to rule 10, the straight line CQ must pass through point M, that is their touching point. Or in other words, CMQ is one straight line. If CMQ is one straight line, it means that CQ total must be equal to CM plus MQ. CM is the radius of this semicircle, this is 5. Likewise, MQ is the radius of this small quarter circle, this is X, according to our definition. So in total, CQ must be equal to 5 plus X. Okay, CQ equals to 5 plus X. So we join points C and Q together one side line, so CQ is 5 plus X. And we implemented the Pythagoras theorem on this right angle QCO. So from the right angle QCO on the new page, and we implemented on it the Pythagoras theorem. CO, side CO equals to 5, this is the radius of the semicircle. So actually, this is the right angle COQ, the according to the original drawing. CQ equals to X plus 5 according to rule 10. CO is the radius of the semicircle, this is 5. And this is a right angle because AOB is a quarter circle. So we implemented the Pythagoras theorem on this right angle COQ according to the Pythagoras theorem. On any right angle, the square of the opponent equals to the sum of the squares of the perpendiculars. So in this right angle COQ, CQ squared, this is the square of the opponent, equals to CO squared plus QO squared. CO is X plus 5, therefore CO squared is X plus 5 squared, and it equals to CO squared. CO is 5, therefore CO squared is 5 squared, that is 25, plus QO squared. QO is the missing side, so we limit this it is. So in total, according to equation 1, we actually found out that X plus 5 equals to 25 plus QO squared. Here we subtracted 25 from this equation, equation 1, and finally found out that according to this equation, equation 1, x plus 5 squared minus 25 equals to q all squared. Again, according to equation 1, we found out that q all squared equals to x plus 5 squared minus 25. The next step, we join points O and P together by a straight line. Point O is the center of this big quarter circle, point P is the point of the big quarter circle itself, therefore OP is the radius of this big quarter circle. It equals to 10 units in the step, according to what is given in the question. The hypotenuse PO is 10, PQ is x, it is the radius of the quarter circle, QO is the missing side. So implement the Pythagoras theorem on this right triangle POQ. So according to the right triangle POQ in the page and implemented on it the Pythagoras theorem. This is right triangle POQ that according to the original drawing. Again, PO is the diameter of the big quarter circle that is 10, PQ is the radius of the small quarter circle that is x, and QO is the missing side. This is a right angle because PQS is a quarter circle, and therefore it is a right angle. So implemented the Pythagoras theorem on this right angle POQ. According to the Pythagoras theorem, PO squared, the square of the hypotenuse, equals to PQ squared plus QO squared. Repeat again, according to the Pythagoras theorem, on this right angle PQO. PO squared, that is the square of the hypotenuse, equals to PQ squared plus QO squared. PO is 10. We just right now found out that PO is the diameter of the big quarter circle that is 10, therefore PO squared is 10 squared, that is 100. PQ is x, it is the radius of the small quarter circle, therefore PQ squared is x squared plus QO squared. QO is the missing side, so we leave this it is. So in total, we should find out that 100 equals to x squared plus QO squared. So here we subtracted x squared from this equation, equation 2, and we found out that according to equation 2, 100 minus x squared equals to QO squared. Or QO squared equals to 100 minus x squared. This is according to equation 2, and according to equation 1, we already found out that QO squared equals to x plus 5 squared minus 25. So we have two different equations for QO squared. Therefore, we can have equation 3 that says that QO squared according to equation 1 must be equal to QO squared according to equation 2. QO squared according to equation 1 equals to x plus 5 squared minus 25, and it must be equal to QO squared according to equation 2. QO squared according to equation 2 equals to 100 minus x squared. So in total, according to equation 3, I found out that x plus 5 squared minus 25 equals to 100 minus x squared. Here we open the brackets of this expression, and I found out that x plus 5 squared equals to x squared plus 5 squared, that is 25, plus 2 times x times 5, that is 10x. So this expression x plus 5 squared equals to x squared plus 25 plus 10x, and we have here minus 25 equals to 100 minus x squared. 25 minus 25 is 0. After we cancel 25, we left in this side of the equation only with x squared plus 10x equals to 100 minus x squared. So here we added x squared to this equation 3, and we found out that x squared plus x squared is 2x squared plus 10x equals to 100 x squared plus x squared is 0. So in total, according to equation 3, we found out that 2x squared plus 10x equals to 100. Here we subtracted 100 from this equation, and we found out that 2x squared plus 10x minus 100 equals to 0. Here we divided this equation 3 by 2, and we found out that 2x squared over 2 is x squared, 10x over 2 is 5x, minus 100 over 2 is minus 50, equals to 0 over 2 is 0. So we found out that according to equation 3, x squared plus 5x minus 50 equals to 0. So this is a quadratic equation. The general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus 4 to b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say x squared plus 5x minus 50 equals to 0, the variable that we are looking for is x. the coefficient A equals to 1, the coefficient B equals to 5, and the coefficient C equals to 150. Well, the only thing that is left to do is to put the data of our specific quadratic equation inside this general formula for x. This way we find out the value of the radius of x, that is the radius of this small quarter circle. The value of the radius of this small quarter circle, PQS. So we put the data inside this general formula for x and found out okay that x equals to minus b, b is 5, therefore minus b is minus 5, plus minus root of b squared. B is 5, therefore b squared is 5 squared, that is 25, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. C is minus 50, so minus 4 times minus 50 is plus 200. So total, minus 4a is minus 4 times a times c is plus 200. So inside the root we have 25 plus 200, that is 225, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total we found out that x equals to minus 5 plus minus root of 225 over 2. That's root of 225 is 15. So in total we found out that x equals to minus 5 plus minus 15 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 5 minus 15 over 2. Minus 5 minus 15 is minus 20, minus 20 over 2 is minus 10. So if we found out that x equals to minus 10 units in its length. But because of the fact that x is the length of this radius of this quarter circle from the radius of this small quarter circle, x as the length, it must be a positive number. So the solution that x is equals to minus 10, it is incorrect solution. So we left only with the other solution that is left for x, that is x equals to minus 5 plus 15 over 2. Minus 5 plus 15 is 10, or 10 over 2 is 5. So according to the second solution for x, that is the radius of this small quarter circle is equal to 5 units in its length. Our test is to find out the size of this shaded area. What is the size of this shaded area? The size of this shaded area equals to the area of the big quarter circle AOB, minus the area of this semicircle, minus the area of this small quarter circle PQS. Okay, again, the size of this shaded area in total must be equal to the area of the big quarter circle AOB, minus the area of the semicircle, minus the area of the small quarter circle PQS. Because of the fact that the radius of this big quarter circle AOB is 10, therefore the area of this quarter circle must be equal to pi times 10 square over 2. So the area of the big quarter circle equals to pi times the radius squared, that is 10 square over 4. Minus the area of this semicircle. Because of the fact that the radius of this semicircle is 5, the area of this semicircle must be equal to pi times 5 square over 2. The area of the semicircle equals to pi times 5 square, that is radius square over 2. Minus the area of this small quarter circle. Because of the fact that the radius of this small quarter circle x equals to 5, the area of this small quarter circle PQS must be equal to pi 5 square over 4. So the area of the small quarter circle PQS equals to pi times 5 square over 4. So 10 square is 100, so in total in the numerator we have 100 pi over 4. Here we have in the numerator 25 pi over 2. So we multiplied both the numerator and the denominator of this expression by 2, and found out that 25 pi times 2 is 50 pi over 2. 2 over 2 is 4. We multiplied both the numerator by 2 and then the denominator by 2, so we change nothing. So total this expression equals to 50 pi over 4, and we have here 5 squared is 25, so in total in the numerator we have 25 pi over 4. So in total, so we took 4 as a constant factor out of those three expressions. So here in the numerator we have 100 pi minus 50 pi is 50 pi, and 50 pi minus 25 is 25 pi over 4. So in total we should find out the area that we are looking for in this question, that is the area of this the shaded area, the shaded region. In total it equals to either 25 pi over 4 square units in size. In terms of numbers, the area of this shaded region equals to 19.635 square units in size. Okay, thank you very much.